New project. The project name is day 7. Importing data file. And serial number we don't require. Import. Create model. The name of the first model is construct validity. So first of all, we have to focus only on the validity aspect. So now the model is done. I am drawing the diagram for validity. The first is TPS. This is the task based stress, and hiding the indicators. Second is role based stress. Then conflict stress. And this is the reward stress. Reward and recognition stress is the full form. And one more, professional stress. So these are the 5 zero order constructs, and these 5 are measuring what? These 5 are measuring the organizational stress or work stress. So let me arrange in this order. Okay, now because I'm going to use the repeated indicator approach, so I will take all the items once again and take it back. So this is simply work stress. So you can see that I am taking all the items once more. And because of this, this method is known as repeated indicator approach. And because all the individual items are reflective, so this is also reflective. So later on you can manage this. I'm just showing you because I am taking all the item again. I am repeating the items once more. Otherwise, most of the time we hide these items. Because we are repeating this item. And this is the step which is the most important step. And all the items should be repeated in such a way that the order of the first level should be same. If all the items are repetitive, this is reflective, this is reflective. If all the items are formative, this should be formative. So this rule we have to follow. After that, we know that this is reflective, reflective. So you just join them as a reflective. Now our second order construct is ready. The next step is to examine the validity. So we can go to calculate consistent PLS algorithm and run it. So when you run it, you will get the result itself here. So work stress, the Cronbach alpha is 0.9, composite levelity is 0.18, and average variance expected is 394. So if you look at first time, you think that this is not a valid construct. Because I got a query from many scholars that my second order construct is not valid. So I'm saying that you are not applying this right method, you are applying the wrong method. So you should not check the composite liability and average variance expected from this diagram. No, this table. It is always wrong. So that's why I'm telling you the right method of calculating the composite liability and average variance expected. Ideally, whenever you apply this table, delete the second order construct from here. and don't use these values. The right values are, you just take this diagram. Now I'm telling the what is the right method of calculating CR and AV. You just export this image and open Excel file. So I'm opening the Excel file, blank Excel file. And put it CR and AV calculation. And we will calculate the value of CR and AV by a formula. So formula, let me show you the formula also. We will use this formula that is reported in the second PPT. So I'm taking the formula also so that you can relate the method we are using for calculation. So we are going to use these two formulas, CR and AV. So these two formulae we are going to use. Here lambda is nothing, it is the path coefficient. So I am taking the graph here. And I am also taking the formula from here. Formula. Now see the formula, how we can apply the formula. So this is zero order construct, task based stress, role based stress, then reward stress, conflict stress, and professional stress. Now we have to calculate the path coefficient. It is 0.843, 0.778, 0.833, 0.789, and this is 0.868. So these are the values which you can see on the lines. So these are the path coefficient estimated by consistent PLS algorithm. So we have to take only these values. You don't take the values calculated by the bootstrap. They may be slightly different. So take only values calculated by PLS algorithm. Now, calculate the square also. So this is the square of the path coefficients. And after that, in the third, you calculate the error, which is equal to 1 minus the square. So these are the error terms. So these three calculations you have to do. Now from these calculations, calculate the total sum of these values. Yeah, so we can just drag it. Decimal only three level. Okay, after calculating the total, you can just directly calculate composite reliability and average variance extracted. So I am putting CR and AVE. Now, if you look at the formula, so this is the square of the sum of the lambda equal to, this is the sum of the square, this is the sum and square. So numerator of CR is sum of the lambda and the whole square. So sum of the lambda and the whole square divided by the same thing, square plus sum of the error terms. This is the sum of the error terms. You just apply this and calculate. Now the formula of CR is coming to this. So this is the right way of calculating the CR, and similarly I'm calculating the AVE. So AVE is simply this divided by this plus this. So the problem, if you feel, is that the SmartPLS always give you the wrong method, wrong value of AVE. So I am repeating this concept. SmartPLS always give you the wrong value of AVE. And because we are using the repeated items, one item 2 times, so that's why AVE should be calculated by this method. So I will share this file with you so that you can see the formulas applicable. So my suggestion is that, because many times, because this is a common problem and asked by many scholars, that how to check the validity of a second order construct, and this is the right method of examining the validity of a second order construct. So now you can see that the CR is more than 0.7 and AVE is more than 0.5. However, if you check the this value, open report, and CR is fine, but AVE value is wrong. So there are many values which are actually wrongly calculated by SmartPLS 4. So that's why this is the point which you should understand.